Okay, so we're going to find all the values of x and y which satisfy this equation. So cos of sine x equals cos of sine of y. Then we'll have a go at sketching this region in the xy plane of all of our solutions. So the first thing we can do to understand what's going on here is we can notice that we've got cos of sine of x, and sine of x can only actually take values between 1 and -1, and similarly sine of y can only take values between 1 and -1. So we've got sine x and sine y are both in this interval between 1 and -1, which is actually quite restrictive now because we're looking at cos of something equals cos of something else, where we need these to be equal, but both of these numbers, sine x and sine y, have to be in this interval between 1 and -1. So if we just draw a quick sketch of our cos functions, let's say we've got theta and cos theta like this. So the only bit we're really interested in is between 1 and -1. So here we've got pi over 2, and 1 will just be over to the left here. So we've got 1 and -1 over here, and this point here is negative pi over 2. So we're only really interested in our cos function in this interval between 1 and -1. At this point, just to make it a little easier to work with, let's say that we've got sine x and sine y. We'll call these a and b respectively. So we'll say sine x is a and sine y equals b. So we're essentially looking for values of a and b so that cos a equals cos b, where a and b are in this interval between -1 and 1. So you'll see the most obvious solution here is just if we have some value of a and b is equal to a, then certainly cos a is going to be equal to cos b. So we got our first solution when a equals b, and this corresponds to the case where sine x equals sine y, where a is equal to b. But then there's another possible solution as well. So if we have a value of a here, we get cos a is up here, but there's another way of getting cos a, which is to use the negative of a here. So this corresponds to the case where b is the negative of a. So we could also have a equals negative b, and this corresponds to the case where sine x equals the negative of sine y. So we've got two possible scenarios here, and you can actually see these are the only two possible scenarios within this interval between 1 and -1. You either have a equals b, and we get the same value when we do cos of a and cos of b, or you could have a equals negative b, and you still get the same value cos a equals cos b. So normally you might expect to get some extra solutions, for example b equals a plus 2 pi. So it would be true here that cos b equals cos a, and we could just see this on a graph of our cos function because it's 2 pi periodic. So let's say we've got a here on our x-axis, and then we add 2 pi, so we'd have b would be a plus 2 pi. It would be true that cos a equals cos b, but then this takes us outside of our region between 1 and -1 that we're interested in. So actually we don't need to consider any extra cases. And the problem then is just reduced to finding all the values of x and y. First of all, where sine x equals sine y, and secondly, where sine x equals negative sine y. And this will give us all the solutions x and y to this equation, cos sine x equals cos sine y. So first of all, if we look for solutions where sine x equals sine y, we could start with just any value of x, then look for all the possible values of y which would work for that value of x. So if we take just any value of x, let's say our x goes here, then you can see that first of all, using the periodicity of the sine function, this is 2 pi periodic. So if we were to have y equals x plus 2 pi, then this would give us another solution which would work. So sine x would be equal to sine y. And similarly, we could have y equals x plus 4 pi, y equals x plus 6 pi, or we could go backwards, we could have y equals x minus 2 pi, minus 4 pi, or minus 6 pi. So if we just write these as, we could say for any fixed value of x, you could have y equals x plus 2k pi, so any even multiple of pi, including 0 here, so x equals y would also work here, and sine x would be equal to sine y. So this works for any positive, negative, or 0 integer k here, and we get all of these solutions. But we've got some more solutions here as well for this value of x. You can see that there's another solution which would go here. So this solution will be y equals pi minus x. So we can write this y equals pi minus x, would give us this solution here. But then we could also do the same thing of adding or subtracting multiples of 2 pi. So we could add 2 pi to this value of x, make that our y value. That would give us sine x equals sine y. Similarly, we could add 4 pi. We could take away 2 pi, take away 4 pi, take away 6 pi. So once again, we've got pi minus x as our initial value, but then we can add any even multiple of pi, so plus 2k pi again, where k is an integer. And we can simplify this somewhat. We'll just rewrite this as y equals negative x plus 2k plus 1 times pi, where again k is just any integer. So you can see here we've now got negative x plus any odd multiple of pi will give us solutions. So these are our solutions in red here. And then we've also got the solutions of the form y equals x plus some even multiple of pi like this. So this will then give us, for any fixed value of x, all of our possible values of y, so that sine x is equal to sine y. And now we'll look at solutions where sine x equals negative sine y. So we can start once again just with any value of x. So let's say we've got a value of x here once again. Then we want to look for values of y so that sine x equals the negative of sine y. So we could take, for example, y equals negative x would work here. So y equals negative x would give us a solution where sine x is the negative of sine y, just using this symmetry of the sine function. But then from here we could also add 2 pi, we could add 4 pi. Once again, just add or subtract any even multiple of pi. So we get loads more solutions like this, but doing y equals negative x plus 2k times pi, where k is any integer. So we've got all of these extra solutions where y is the negative of sine x, but we also get some more solutions. For example, here we would have y, if y was equal to, this is x plus pi, so let's just label this. On the x-axis this would be x, then this new point here would be x plus pi. So you can see that sine of x would be the negative of sine of x plus pi. So this would also work if we had y equals x plus pi would give us this solution in red here. And this would also work, and then we could also add any even multiple of pi to this, or subtract any even multiple of pi to this. So now we've got all of the possibilities where y satisfies sine x equals negative sine y by taking x plus pi plus 2k times pi, where k is any integer, just adding any multiple of 2 pi here. And we can simplify this second expression again, just like before, into y equals x plus, will be 2k plus 1 times pi, where k is any integer. So we've got, first of all, y equals negative x plus any even multiple of pi gives us sine x equals negative sine y. And second, we've got y equals x plus any odd multiple of pi gives us sine x equals negative sine y. So we've now got 4 different sets of solutions, but we can actually combine these into 2 slightly nicer expressions. So first of all, we had in case 1 where sine x was sine y, we had y equals x plus any even multiple of pi would give us a solution. But we've just seen here y equals x plus any odd multiple of pi would also give us a solution to our equation. The only difference being, instead of sine x being equal to sine y, we'd have sine x equals the negative of sine y. But this would still satisfy our original equation. So we can break this down now into just 2 simpler cases. We've got y equals x plus, and we can just say any multiple of pi, where k is any integer, because we've got all of the odd multiples satisfy our second case, and all of the even multiples satisfy our first case. So just actually x plus any multiple of pi would work. And similarly, we've got y equals negative x plus an odd multiple of pi worked in our first case, and here y equals negative x plus an even multiple of pi works for our second case. So we can actually combine this into just a single case once again. Y equals negative x plus k times pi, where k is any integer. So it looks like we had 4 cases, but by combining the odd and even cases into one, we actually just get these as all of our solutions. So for any fixed value of x, you can look at, first of all, y equals x plus pi, y equals x minus pi, and so on. But then we can also have, for a fixed value of x, y equals negative x, then add, subtract any multiple of pi from that, and that will also give us more solutions to our original equation. So this encapsulates now all of the solutions, x and y, to our equation, and we'll finish now by trying to sketch what this region looks like in the xy plane. You can see that our region is just going to be made up of lots of straight lines. So we start just with the line y equals x, where k is 0, to get us started. This is our first part of the region we can draw. Then we can have y equals x plus pi, y equals x plus 2 pi, and so on. So if we just very carefully draw these now, and you'll see the y-intercept will be at pi, and the x-intercept will be at negative pi for y equals x plus pi. Then similarly for y equals x plus 2 pi, we can keep going like this, y equals x plus 3 pi, and we get all of these parallel lines now that are pi apart, horizontally and vertically. And we can also do, for k negative, we can do y equals x minus pi, so we can have y equals x minus 2 pi, and so on, and we get lots more of these parallel lines. So our first set of solutions is actually just this collection of all of these parallel lines then, y equals x plus pi, y equals x minus pi, and so on, like this. So then we can look at our y equals negative x plus different multiples of pi. So let's just start with y equals negative x. So this will be perpendicular to all of these lines, and y equals negative x will look like this. So then the next one, if we do y equals negative x plus pi, we'll have the same y-intercept here, and our x-intercept will be when x is equal to pi. So we just draw in another parallel line like this, and similarly y equals negative x plus 2 pi would continue like this, y equals negative x plus 3 pi would carry on like this, and so on. So we get this nice grid pattern, and this would continue all the way over here, extending off in all directions. And we can also have y equals negative x minus pi, y equals negative x minus 2 pi, and so on. So if we have minus pi, this is going to be our y-intercept, and we get the next line in our grid like this, y equals negative x minus 2 pi down here, we can draw in, and y equals negative x minus 3 pi, we can draw in minus 4 pi, and so on. This grid would just continue extending off in all directions now. So this is what our set of solutions looks like then to cos of sine x equals cos of sine y. It's just this collection of all of these lines, y equals x, y equals negative x, then plus or minus any multiple of pi.